triangles and its properties, exercise 6.4. So the first question is the sides of a triangle are 7 centimeter and 12 centimeter. What are the possible lengths of the third side? Okay, so this is based on triangle inequality property where you have three sides AB, BC and AC suppose. And so the property says that the sum of any two sides will always be greater than the third side. Similarly, you take BC plus AC, it will be greater than AB. And if you take AC plus AB, it will be greater than BC. So as we know that sum of the two sides should always be greater than the third side. So it means that we add it, we get 19. So the third side should not be greater than 19. Okay, so the maximum we can have is 18. It should be less than 19 basically. Not 18, but it should be less than 19. And for the least, we subtract the two numbers. So it is 5. So the minimum should be greater than 5. Okay, so we can say that the length, if we call it x, should be between 5 and 19. Let's have a look at the next question. So again, it is a similar question. So again, you have to find the range. So range is calculated by adding and subtracting the two sides. Range means that what could be the maximum or the minimum or the possibilities of the third side. So here we can, so we will add them up first. So it is 14, and when you subtract it, you will get, so the range is where x is the third side. Okay, let's have a look at the next question. Now, can a triangle have sides 6, 8 and 15 centimeters? Justify using the triangle inequality. Now here we'll apply the property of triangles inequality. So we'll check it for all the three sides. So let's check for 8 plus 6. Okay, now here you see that when we add these two sides, we are getting 14, which is less than the third side. Now, according to the property, the sum should always be greater than the third side. So here at the first attempt itself, we are getting that it is not. So hence we will say that this measure of sides is not possible. It doesn't make a triangle. Okay. Okay, question number 4. Check whether sides 10, 4 and 7 form a triangle using the side sum property. Same thing, you will take the two sides at any point of time and find out if it is greater than the third. Now this is 14, it is greater than 7. Let's take 4 plus 7, it is 11, which is greater than the third side, which is 10 centimeters. And the last combination is 7 plus 10 makes 17. Now 7 plus 10 is 17, so which is greater than again 4 centimeters. So hence these sides will form a triangle. Okay. Now in this question we have a triangle. So in this question we have a triangle ABC again. ABC, and we are given that AD is the median. So here AD is the median. So now what happens that here we have got two triangles because AD is dividing this triangle into two parts. So we will apply the triangle inequality property on both the triangles. So let's take, so in triangle ABD, what do we have? Can we say that AB plus BD is greater than AB, sorry, AD. Now, why am I taking this? Because see, we have to prove AB plus AC. Now, where is AB? So, this is AB and AC is here. So, we have this side AB, right? And on the other side, we are talking about AD. So, we need to have AB and AD in this. So, when we are taking one side, we are getting AB also and AD also. Okay. So, now let's move on. Now, similarly, we will also write for the other side of the triangle. So, in triangle ACD, we can say that AC plus CD is greater than AD, right? Now, we will add respective sides. Are you done? Respective sides of 1 and 2. So, it is AB plus BD plus AC plus CD. Okay, now greater than AD plus AD. Now AB is will keep as it is. AC will keep as it is. But do you see BD and CD together make BC? So we will write it like this. And you know that AD plus AD is twice AD. So hence proof. This is what we were supposed to prove. Okay, I have forgotten to write here the third side, AB, AC and BC. So here also we have got a triangle and a median. So XM is the median. So I'm calling it X here. M is the median. Now this is Y and this is Z. So there are two triangles in this. So we will say in triangle XYM, we have XY greater plus YM greater than XM. Now, how do we choose that which one to keep where? Because you can see that in this inequality, XM is on the right hand side and we have got two of those. So, we have two triangles, right? So, we can like use it twice on both the triangles. So, first we write this and then we have got triangle again in triangle XZM. We can say XZ plus ZM is greater than XM. So now we will add both sides. So we can say that from 1 and 2, add the respective sides. So xy will remain as it is, plus xz will remain as it is. Ym and zm would make yz together, and we have got twice of xm here. Okay. All right. So in this question, we have got a quadrilateral. So a quadrilateral, let's draw it. And in this is A, B, C, D. We have to prove that the sum of all the four sides is greater than the sum of its diagonals. Okay, so let's here we have to focus on the diagonals, right? So let's take first AC as a diagonal. So if AC is my diagonal, then I will have two conditions. So first, in triangle ADC, I can write AD plus DC is greater than AC. Let me call it 1. Then in triangle ABC, I will have AB plus BC greater than AC again. Okay, now let's have a look at BD and let's see what all we will get. So again, in triangle ABD, I will have AB plus AD greater than BD. This is third. And in triangle BCD, we will have BC plus DC greater than BD. So what we are doing, our focus is on the diagonals. Okay, so what all conditions we can have based on these the triangle inequality property, we are having it here. Now what we'll do, we'll just add them up. So from 1, 2, 3 and 4, add the consecutive, the respective sides here. So we will have AD plus DC from 1, AB plus BC from second, AB plus AD from third, and BC plus DC from fourth. Now it will remain greater than again the sum of all the sides, because just adding the respective sides will not change the inequality. So now here whatever we can combine, we'll combine that. So you can see that I have got 2 ADs, right? Then I have 2 DC also, I've got 2 AB also and 2 BC also, right? So we can say that we have got, now if you want to write it like, one step at a time, you can write it like this. Or you could have done it like all together. I'll tell you how. Now here I have 2 AC and 2 BT. So what we'll do, we'll take out 2 as common factor from all, and we'll be left with this. Here also we'll take out 2 common, and you know that this 2 will get cancelled out from both sides. You can say we are dividing both sides by 2, and hence proved this is what we were looking for, that sum of all the 4 sides of a quadrilateral is greater than the sum of the diagonals. Okay, done?